Hello, ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss linear functions. So a linear function is a function whose points lie on a straight line when a function is graphed. So a linear function is a function whose points lie on a straight line when the function is graphed. There are many ways to determine if a function is linear. One way is to use a table. So today we're going to determine if a function is linear by using a table. And there's 3 steps. Step 1 is we want to find the difference between each x value. So step 1, we want to find the difference between each x value. And remember, your x value is also known as your domain and your input. So your x value is also your domain and your input. Step 2, you want to find the difference between each y value. So step 2 is you want to find the difference between each y value. Remember, your y value is also known as your range and your output. So step 2, find the difference between the y value, which is your range, and your output. And then the last step is you want to write the ratios using the difference. So step 3, we want to write the ratios using the difference. Make sure you simplify those ratios. So if the ratios are the same after you simplify them, then the function is linear. So if the ratios are the same, then the function is linear. If the ratios are different, then the function is nonlinear. So if the ratios are different, then the function is nonlinear. So let's do an example together. So example 1 states, determine if the function represented by the table is linear. So step 1 says we want to find the difference between each x value. So our first difference, we're going to go from -2 to 0 in our x value. If you notice here, our difference is 2. We're going up by 2. Then our next x value from 0 to 2, we're also going up by 2. That's your difference. Then our last, from 2 to 4, is also a difference of 2. Now in step 2, we want to find the difference in y values. So we're going from 4 to 7, and that's a difference of 3. Next, we're going from 7 to 10, and that's also a difference of 3. And lastly, we're going from 10 to 16, and that's a difference of 6. So now step 3 is we want to write our ratios using the difference. So we're going to write our ratios by using our difference in our first x and our difference in our first y. So our first ratio is 2 to 3. Is that simplified? Yes, it is. Then we're going to write our second ratio. Our second ratio is the difference in x over the difference in y of the second. So our second ratio is going to be 2 over 3. And then our third ratio is our third difference over our third difference in the y, and that's 2 over 6, which can be simplified to 1 over 3. And now you're going to ask yourself, are these ratios equal? Well, is 2/3 equal to 2/3? Yes. But is 2/3 equal to 1/3? No. Therefore, they're not equal, so this is a nonlinear function. So since the ratios are not equal to each other, your answer is going to be nonlinear. This function is nonlinear. Let's do another example together. So let's look at example 2. Determine if the function represented by the table is linear. All right, so our first step is we want to find the difference in our x values. So we're going from 3 to 5, and that's a difference of 2. We're going from 5 to 9, which is a difference of 4. And then we're going from 9 to 15, which is a difference of 6. Our next step is to find the difference in our y's. So we're going from 10 to 6, which is a difference of 4. Actually, we're going down 4, so it's -4. Our next is 6 to negative 2, which is a difference of negative 8. We're going down by 8. And lastly, we're going from negative 2 to negative 14, and that's a difference of negative 12. So now that we found the difference, we want to identify our ratios. So our first ratio is 2 over negative 4. So we have 2 over negative 4. And can that be simplified? Yes, it can, to negative 1/2. Our second ratio is 4 over negative 8. So we have 4 over negative 8. And can that be simplified? Yes, it can, to again another 1/2. And then our last ratio, we have a difference of 6 over negative 12. So 6 over negative 12. And can that be simplified? Yes, it can, to negative 1/2. So always remember to simplify your ratios. So always remember to simplify your ratios. And then you're going to ask yourself, are these ratios equal to each other? Is negative 1/2 equal to negative 1/2? Yes, it is. And is that also equal to negative 1/2? Yes, it is. When all the ratios are equal to each other, therefore the function will be linear. Therefore, our answer is yes, this function is a linear. This table represents a linear function. Let's look at one more example together. Example 3. Determine if the function represented by the table is linear. Our first step, find our difference in our x. So 5 to 7 is 2. Then 7 to 10 is 3. And then 10 to 14 is 4. Now let's look at our y values. We have 2 to 4, which is 2. We have 4 to 6, which is also 2. And then we have 6 to 8, which our difference is also 2. So our next step is to write down our ratios. So our first ratio is 2 over 2. So 2 over 2 simplifies to 1. Our second ratio is 3 over 2. So our second ratio is going to be 3 over 2, which simplifies to 1 1/2. But you can just keep it as 3 over 2. And then the next one, our last ratio, is 4 over 2. So 4 over 2. And 4 over 2 is equal to 2. And I want to identify, are these ratios equal to each other? Is 1 equal to 3 over 2 equal to 2? No, these are not equal to each other. Therefore, this function represented by this table is nonlinear. So this function is nonlinear. So now what I would like you to do is the u-try section. So for the u-try section, for the tables below, determine if the function represented by the table is linear. I would like you to determine if the first table is linear and also the second table is linear. And we will discuss it in class. Thank you.